Okay, so welcome back to our third session, which is the first session after lunch. And we'll try to get things away on time with Paul McKenney's talk on respecting semantic dependencies. Okay,
thank you,
great.
sir. So they said they wanted rants. This is a rant. Now, this is my first ever official rant. So I felt the need to, official rant. So I felt the need to get some guidance, so I talked to a prominent academic who was also highly placed in this conference, and he was very understanding and kind. But the advice he gave to me was, Paul, just be yourself. And the people who know me already know that they've been warned. So there were a couple questions I didn't get a chance to ask Lynn last time, and one of them was GPUs. I did have a chat with a GPU vendor who does have concerns about performance with forcing loads before stores. And undefined behavior and all the examples, but here we are. What I'd like to do is kind of get a sense of the room. I've got this title here, compilers should just get over themselves and respect semantic dependencies. How many people feel that's tautological? That's just the way the world is? Okay, yeah, a few of them, all right. How many people believe that it's not tautological as written, but if you were to add a few reasonable qualifiers, it would in fact be tautological? Okay, got a few there, okay. How many people think that it probably is true, but there's a huge amount of work between here and actually getting that? Okay, a few more. How many people aren't really sure? I mean, same deal, a lot of work, but aren't really sure what the answer would be? All right, yeah, some assertive people there too. Good show, good show. How many people think it's probably false, but again, it would be a huge amount of work to prove it? Okay, yeah. And then how many people think it's just false on the face of it? I mean, it just doesn't make any sense at all. It's anti-tautological, as it were. Okay, yeah, all right. Brave man, good show. How many people think it's just a matter of opinion, really? Oh, no takers on that one. We got one poll result with no, oh, okay, thank you for filling in. Wouldn't want to have a zero after any of those, after all. Okay, well, we'll talk about that a little bit. The meantime, first thing I'm going to do is go over some properties of semantic dependencies. I've had a lot of people tell me that semantic dependencies must be one way or another way, and we'll go through a few of those and see what we end up with. One really nice thing is that you'd like the static dependency to be a property of the code fragment. So you got the code, and it either has static dependency between here or there, or it doesn't, and life is good. How many people agree with that? Okay. The thing is, you got things like this. And I'm using weird notation here. For variety, instead of capital A, capital B, capital C, I'm using X, Y, and Z for the shared variables. R1 and R2 and so on are the locals. The locals are initialized as 0, just to save a little space on the slide. And so what we got here is we're going to do a relaxed load from X. If the value loaded is non-zero, we're going to pick up R2 from Y, relaxed load as well. And of course, if R1 is 0, R2 will keep its initialized value of 0. And then we're going to multiply those two things together and do a relaxed store to Z. And my question to you is there a semantic dependency from Y to Z? Okay, we got, so even if R1 comes back 0 and there is no load instruction, there's still a semantic dependency? Yeah, and I think I think the gentleman over there, he said the word execution, and that's the trick here. I mean, the thing is, this is per execution. If you have to, instead of looking at it as a code fragment, I'm sorry to the people that want it that way. It's not really, it often is. I mean, there's a lot of code fragments where for all executions, the semantic dependencies there are not, but there are some cases where they can come and go. Now, you can quantify across all the executions. You could do something like say, well, if any one of them has a dependency, I have to preserve the dependency, therefore I'm going to look at it that way. Or you could be an analysis tool and say, if there's anyone where there's not a dependency, you can't count on it. Okay. But the problem with that, of course, is that we have a lot of compiler people, and compiler people like optimizations, and they like specialization optimizations, where you have a bunch of cases, and in this case, there's no semantic dependency, in this other case, there is. Well, you'd like to optimize this separately and get rid of the semantic dependency, make it go faster. And so those guys are going to want to think of this stuff as per execution. So I think we really have to accept the fact that semantic dependencies are not a function of the code itself, but of executions of that code. Go ahead.
So does your argument apply to non-atomics as well, or only for lexical?
I'm talking only about atomics. If you, in C and C++, the languages I'm worried about, not Java, okay, but in C and C++, if you have non-atomics and you let them race, that's undefined behavior. And we saw in the last presentation some examples where funny things happen. Go ahead.
The program does not need to think about semantic dependence at all about non-atomics. That's your argument.
I'm not sure I'm going to go that far, but I'm going to say that non-atomics that race, the question was, I don't have to worry about semantic dependencies at all for non-atomics. I'm not going to go that far. Instead, I'm going to say that if you have data races, you have undefined behavior, your program has no semantics, and so the question of semantic dependencies becomes irrelevant. All right, because you may have to trace semantic dependencies through non-atomics, or not, as we'll see. Okay, you'd like it to be inherent in the language standard. Okay, you got this nice standard for C, you got one for C++, you got a bunch of other standards, and you'd like to be able to look at the standard and work out what the semantic dependencies are. For C and C++, sadly, you've got guys like this. Pretty simple function named foo, why not? It takes a character as a parameter, it returns a character, and we take that character and we add 200 to it.
That's non-atomic.
That's true, and so that was possibly answered your question. Presumably, for it to be relevant, this is not communicating. Presumably, for it to be relevant, there's something else. They call this function that did an atomic load and then takes and does an atomic relax store based on it. Okay, but this is strictly non-atomic. We also don't have any. It's single-threaded as well. And the thing is there a semantic dependency from that parameter C to the return value? You're all right. The answer is sometimes. You see, the C standard and the C++ standard don't specify, I should say, whether char just by itself is signed or unsigned. If you happen to be running on an architecture that has decided that char is unsigned, this is perfectly well defined, there is a semantic dependency. If you're running on an architecture that happens to have 8-bit bytes, and it has signed chars, this is guaranteed undefined behavior because of integer overflow. And then there might be a semantic dependency or not, but the program has no semantics, so who cares?
Cool.
Yeah?
Cool. Undefined behavior, you called it on the wrong thing.
Is it undefined behavior if you called on the wrong thing? You can come up with examples where if you give it the wrong thing, it will result in undefined behavior.
So the definition of undefined behavior is only a property of whole program.
True, but you could. But in this case, again, I'm not doing the standard. I'm saying bytes are 8 bits. Okay. And in this case, if I have an 8-bit byte and it's signed, the largest value it can represent is 127. All right.
If you're in a program that only uses this with nice small t, then there's no undefined behavior.
Okay. You're right. I messed up. I should have made it 300.
It doesn't have, no snippet has undefined behavior in isolation.
Really? If I say p equals null star p, that doesn't have undefined behavior?
If it's not called, then no.
Okay. I'll put the qualifiers in if it is called. I'm sorry?
Yeah.
Well,
Promotion,
yeah.
messing things up. So you have to write something a bit more complicated.
Okay. I'll accept that. And in any case, I'm going to assert that I could write an example that on some architectures would, if ever called, would do undefined behavior, and other architectures would define behavior. And I apologize for my mistakes here, which is why I need compiler diagnostics, and among other things. Okay, in any case, the signedness of chars per architecture. We do not like this in the Linux kernel, and so we give the compiler this guy that forces the chars all to be unsigned regardless of what the architecture wanted. All right, And so the standard is the beginning. Semantic dependency is not defined strictly by the standard. You'd like these things to be deterministic. They might not be, okay? This is foo again, but with two unsigned ints coming in, x and y. This is single-threaded, returns an int. We take x and multiply it by star x and plus y divided by plus y. Let's assume that the y passed in is 0. Okay, then you plus y, you get 1 on the numerator. You plus again, you get 2 on the denominator. You divide that, it truncates, you get 0. You multiply x by 0, and it's not going to matter what x was, you're going to return 0 no matter what, if y is 0 in that case. On the other hand, if it happens to the denominator first, you're going to get 1 on the denominator and 2 on the numerator. You get the value 2, multiply x by 2, you change x, that's going to change the return value, so there's clearly a semantic dependency there. So there are things in the standard, and the problem was is that they couldn't get people to agree on any order, and I'm not sure what agreement you could come to on what order you should do side effects and expressions. And so it's not specified. What a lot of projects do is they say, don't do that, okay? And the thing is, sometimes you have to. But the thing is that we luck out with compilers because the compiler freezes its non-deterministic choice into the binary, and then life is reasonable. You work the binary level and get something sensible. But it's still a potential problem. Now, another thing you'd like is you'd like semantic dependency to be defined within the confines of the abstract machine. Okay, you'd like to be able to analyze the abstract machine, whatever it ends up being after all this, and then get semantic dependencies out of that. But thus far, the record of that approach is kind of against it. Now, I'm not trying to cast shade on the people who chase this. They've done a lot of hard work, but we don't have a sharp definition of semantic dependency that's usable at this point, which indicates we should do something else. The other point, and this is something that my predecessor before lunch brought up, is that real systems are not Turing complete. And that means that if you're using the abstract machine, it is Turing complete, and there are some problems you're going to run into that you won't run into with real implementations running this stuff. And finally, standards are not mathematical objects. I mean, if you've actually participated in a standards meeting, you know that. But I'll have a slide on that. I'm not going to go through volatile. We don't have the time, but that usually gets some excitement going. I would argue that the part of the C++ standards that's closest to math, and it's not all that close, is the memory model. It was developed with support of mathematics from some people in this room, and that was really cool. That might be the first time that happened. But as we saw from Hans's presentation, we got 15 years on, and we're still finding bugs. Okay, so C pointer provenance, we've added some math. I'm not going to go into that. We're running short. But the other thing is to be careful what you wish for, right? Just because it's math doesn't mean you can solve it. Now, we did solve FLT, well, Andrew Wiles did in 1994. Collapse conjecture is still open. Again, we'll skip volatile. The thing is that if we want to worry about STEP, and I can see a lot of annoyed faces at this, and I'm sorry, but we have to really step outside of the abstract machine. So what do I really think? You know, if it's called a semantic dependency, I mean, it's got this word semantic in it. And that means if the compiler breaks it, well, either somebody chose the wrong definition, in which case you might choose a better one, or your compiler's buggy, in which case you might fix the compiler, although we had a debate in the session before lunch about whether a certain thing was a compiler bug or not, so your mileage may vary. Or, as was brought up in one of the objections to my previous thing earlier, that dependency might be in meaningless code. And that code might be meaningless because it contains undefined behavior, however you want to say that, or the dependency might not affect observed behavior. Maybe it's dead code and gets eliminated, in which case the dependency is eliminated too, or perhaps it calculates some result that then just kind of gets discarded and doesn't affect things, all right? So if we have a meaningful dependency, the compiler really has to pay attention to it, otherwise it's going to get a wrong result, no matter how you define semantic dependency. And compilers have been doing this for a long time. Been around for 70 years. That's even longer than I am old, okay? They've been longer than I have. Not many years longer, but longer. And we've had to do this for register allocation in the 50s. Vectorization needed to worry about dependencies, and we're having to worry about them now. We've been able to rely on that with some pain and agony, and so this should be something we should be able to continue doing for some period of time. Now, I hope that we come up with something that does better, but we're not in a bad place at this point, I would argue. What we can do instead, we said, I think we've got agreement more or less we should have semantic dependency be per execution. I think we need to think in terms of real systems to make this actually work well. Again, I see some people that aren't happy about that, but I'm not here to make you happy. I'm sorry. This is a rant. That allows the physics. I think we need to accept that there will be special purpose definitions of S-step depending on what you're doing, just like there are in many other situations for other things. Approximations to it, and I think we need to accept that people will be applying that, not necessarily always at the source level, but also the object level too, in implementations involving compilers. And I suspect there'll be a lot of other things as well. Okay, there's a lot of people who have helped with this. I'm not going to, and I'm going to read the last line because it's important. Please note that appearance on this list in no way indicates any sort of endorsement of any part of this rant. All right. And there's a lot of other people I've worked with, but those are the ones that came to mind immediately when making the slides. I'm going to disconnect this so that the guy coming after me can figure out what's going on with the projector, and I can take questions for a few minutes.
Great. Okay, thanks.
I'll go over here.
Okay, any questions for Paul? We've got 3 or 4 minutes.
It's less of a question than something of a comment. So C actually has something that is a form of dependency that is in the abstract machine, and you don't like it. It's called pointer provenance.
It actually has several. One of them was covered earlier this morning with the bit about not introducing data races, meaning that you have to respect control dependencies if the thing in the if statement is a non-atomic right.
Right, but that's not explicitly in the standard, right? Like, usually semantic dependencies are something we define in terms of, like you define your language and then you can have a derived notion which is what are my semantic dependencies.
Okay, so let me try restating what you're saying. What you're telling me is the compiler writer is happy to respect dependencies as long as they make me angry. Sorry, couldn't resist.
Maybe, I don't know.
Help me out though. In what way is pointer provenance a dependency in this sense?
I mean, the most direct version of dependency that I know in the C standard is how restrict is specified, where they even say something about if changing this value changes that value or something, which I don't know anybody who knows how to interpret that. But the actual interpretations of
that's usually the case, right?
Are all based on provenance, as in you add some magic ghost stuff to the pointer, and then you can track in a single execution how it flows to the program. Because otherwise, dependency is more like a hyperproperty. You can't really talk in a single execution about dependency. You can only talk about it by relating multiple executions. If you want to do it in a single execution, the only thing I know is provenance, but most systems programmers don't like provenance. So
I'm happy to, well, I don't mind provenance. I just want some way to keep the compiler from going crazy with it. I just want some way out occasionally. I'm okay with it being there in general. But thank you for the thing about restrict. I will keep in mind that there actually is some dependency in the standard and use that with as much effect as I can.
Okay.
Maybe another question there somewhere too. But
so in compilers, there are a lot of speculative optimizations they perform, like speculative load introduction and so on. So do you consider in your definition that is it a semantic dependency or it is a breaking semantic dependency?
So there's a lot of things you might mean by speculative load. In the hardware, we have speculation. And what happens is that you speculate and then you execute speculatively, and then if your speculation turns out to be wrong, you throw it away and start over. You do the same thing to compilers. And that's fine, okay, as long as you actually check. If you speculate and then don't bother checking, that's a bug waiting to happen, right? So, but the check has to be done after you know what the load really was. And then that makes things work out. You got a temporal relationship there, and life is good.
Okay, any other questions there? Yeah, I was going to say, we've got time, yeah.
Help out our next speaker, ask some more questions.
Can you give me an example of semantic dependencies which compilers should respect?
Can I give you an example of a semantic dependency that compilers should respect? Okay. If you have two numbers and you add them together, it'd be really good if it actually got the sum. Right?
depends on what?
Well, the sum depends on the two terms coming in, right? So the value of the sum depends on the value of the addends.
Okay.
You got one behind you and one up
Yep,
there.
yep.
So
Up there.
What was your example of concurrency primitive from the 70s?
LIFO stack push. So you use compare exchange to push one element on the stack, and then use an exchange thing, like the thing that was pointed at the bug that Luke pointed was a buggy in the compiler, to yank the whole thing off at once. And come to me and I'll show you, we got some papers that go through it. I'm not going to try to go through it right now. I hopefully he gets, I mean I could, but hopefully he gets his display working before I get done.
Yeah.
So the motivation of semantic dependence is to rule out of thin air? Is that main motivation, or what's the?
That's one use of it. If you have semantic dependencies and you actually have to compute based on the value when there's semantic dependency, and you're running on a real system, there will be global time will advance from the point at which you do the load till you do the store.
Okay.
And that will get the load store ordering that our gentleman this morning, Stephen, wanted for free, as he pointed out.
So
And it will also allow a number of optimizations to be taken out. Right now, they're just really careful with optimizations because they're worried about introducing OOTA.
yeah.
Go ahead.
Okay. Then in the afternoon, in my talk, I will tell you something about the related things.
Okay, that should be fun. Looking forward to it.